Hi, my name's Ian. I'm an engineer. I've done some business and I'm a dad. So I'm worried about what's going to happen. I'm worried about the future. Worried about climate change. And I've been feeling more positive lately because of this molecule right here. Nitrogen and hydrogen. You can make it from green power. When you consume it, when you burn it, it burns totally green. And so we have a green fuel. Um, and that makes me, exploring this has put me in a good mood. All right. So, what do I mean by green fuel? Well, for example, Wärtsilä here, they are making a flex fuel motor so it can run on diesel um, and it can run on ammonia, nitrogen, hydrogen, green ammonia. Um, so you can replace fossil fuels. You can also offset fossil fuels. So instead of having a new motor, if you put ammonia and emulsified it into diesel, your current diesel could run on 10% ammonia, which to offset 10% of the greenhouse gases without changing any of our infrastructure, that sounds pretty good, right? But there's another element to this, which is power production. So when we make power, it's the peak power that's expensive, right? That's when we turn on our gas plants. Nuclear will do base load, right? Um, but we need something, and so the energy efficiency from making ammonia and then feeding it back into a gas plant. What's your energy loss there? It's a lot, but it doesn't mean that it doesn't make sense um, to do the chemical storage. So to take electricity and to turn into a chemical, and then to consume that chemical to burn it in a turbine to make electricity. There's heat loss and all these sorts of things along the way, but could be 24%, 31% efficient. Um, because it's totally green that whole way, that's not that bad actually. Um, so I've been thinking about this power system thing, right? How does it really work? How's the matching work, right? So this chart shows the market demand. So in Ontario, we're also connected with the US and we're also connected with Manitoba and Quebec. So there's the demand, uh, Ontario demand and overall demand. And we don't love sharing power between spots, but we do it all the time. But we focus on Ontario first. Um, so this is yesterday. You can see the power over the course of the day moves around, and the production moves around to meet that, right? So the blue on the bottom is nuclear, so that's dead flat, right? Red is natural gas, green is hydro, um, and you can see it there a bit. It was a really not windy day, so there wasn't a lot of wind. Um, but that's gonna happen with green power. Solar, you barely blips up at all, but I mean, I think we've had like a couple hours of sunlight in the past 2 months. So um, it's just what you expect, right? Um, so here I flipped it into a percentage so you can see how the percent from each source changes. Right? So, you know, looking here, it feels like you could produce a lot more wind, and that would simply offset your natural gas, right? You'd still keep the gas, but it feels like you could build out and build out and build out your wind capacity, um, and the system would still work. Um, and that's probably somewhat true. All right. So Ontario energy capacity versus utilization. So our wind capacity is 13% of our overall capacity. Our gas capacity is 27%. Wind, how much of that capacity do we use? Sorry, how much of our overall use is wind is 9%. So 9 to 13 is pretty close. And you have to remember it's not blowing all the time, right? And our gas is less than half. So we have a lot more gas capacity that we just keep offline um, for peak power, right? Now, that gas could be converted to run on green ammonia to run that peak power. So it doesn't cost that much. So basically, you're using one fuel versus another fuel, but you've already paid for the infrastructure. Um, all right. So here, thinking about the imports and exports, we even on a daily basis will sometimes be importing in the morning and exporting in the afternoon, or vice versa. Um, so there's a balance to this, and this all matters in the system, right? It's a complicated interconnected system, um, which makes decision making very difficult, which makes policy making very difficult, predicting the future difficult. But here's an interesting piece, and this is not a criticism, it's just an interesting piece. Ontario has a nuclear plant, has hydro, and some days we're not using that much power. And sometimes on those same days, it's really windy, right? So we actually end up dumping a fair amount of energy. So these stats come from two different sources. One's the Fraser Institute, and one is an engineering society. So Fraser said in 2016 we dumped 7.6 terawatt hours. Engineers said in 2019 we dumped 6.5 terawatt hours, so dumped. So, I mean, they talk about how many houses or how many billions of dollars. I want to talk about um, if we could get free electricity to make ammonia, how much ammonia could we make? All right. So, um, if you convert the 6.5 million megawatt hours, it takes about I'm using a company's stats, so people who build a unit, they say they can they use about 9.07 megawatt hours to make a ton, so that turns into 700,000 tons. Um, Ammonia, it's a commodity, so sometimes it sells for more, sometimes it sells for less. So what is the price? The price kind of fluctuates between 500 and $1,500 a ton, but let's say it's $550 a ton. Well, that's almost $400 million of ammonia you could make with um, the electricity we dump, right? And that ammonia, totally green, we could use in the gas plants to offset the natural gas. Um, we could use it to replace diesel, like that motor, to offset some diesel, so we could blend it into the diesel the trains use, right? $400 million of ammonia. Now, you're going to say, well, that's the revenue. There's other costs, right? Even if you have free power, what's your plant maintenance, etc. So obviously utilization things matter, but I've just grabbed some statistics, levelized cost versus electricity cost, right? So we have a couple different graphs here. This is the cost. The straight ones are if you make ammonia with natural gas. So if you make it with natural gas, your cost of electricity doesn't really matter. And then the lines that go up show your cost depending on the cost of electricity. And the tipping point is, 20 bucks a megawatt hour, something like that. If you have a megawatt hour for free, it's less than $100 a ton, right? So if you can sell it for 550 and make it for 100, you're talking $300 million of profit, right? It's a commodity. You can sell it into the global market. That's really interesting. I personally, I think that's really interesting. So, I mean, there's big business cases, uh, if you can lock in some power, right? So, anyway, um, good news. Ammonia is going to be big and it's going to be green. Cheers.